So, want to do a quick little video here on relative velocities. Still going with special relativity here. And the situation we're going to have is that we're going to have an observer. We'll call him A. This is our observer. Okay? And then we're going to have someone at B. Someone B. This is our someone who is moving. And they will move at velocity v, where v is relative to a. It's their speed relative to a. So b is actually moving. And then b either fires a projectile or something like that. And what we have is another third object or system or something like that that is moving relative to b, and we'll say that their velocity relative to b is u prime, and they'll also have a velocity relative to a, which we'll just call u. Okay, so this is relative to b, and this is their velocity relative to a. So the question is something like A sees B. So let's say like B is a spaceship flying along at speed v relative to A, okay? And so it's a rocket ship going on somewhere near the speed of light. And then so it could be something like 80% the speed of light, so 0.8 c. And then it fires a missile that it would, if it was sitting still, it could fire a missile at half the speed of light, so 0.5 c. That would be u prime. So it, from its own perspective, fires this at half the speed of light. Well, what speed would this missile that was fired, or this rocket that was fired, or whatever, what speed would it appear to be relative to A? If A looked at it, what speed would it get? Would it get the 0.8 plus the 0.5 c? Because then it would be going faster than the speed of light. So how do we actually come up with how fast this object is going? So let's derive an equation for that, and then we can, you can use this to solve this kind of problem. So let's start with u prime. All right, let's derive what u prime is. Well, u prime is delta x prime over delta t prime. Okay, and if we do that, this is gamma times delta x minus v delta t. Okay, because remember, this is the speed of b relative to it. That's what that's going to be. And then delta t is gamma delta t minus v delta x again over c squared. Okay? If we take this now and we see that the gammas will cancel out, isn't that nice? Not to have to worry about that gamma, at least at the moment. And then if we take this whole thing and we multiply both the top and bottom by 1 over delta t, okay, just a little trick there. What that's going to do is give us delta x over delta t, okay, delta x over delta t, and it's going to give us minus delta t over delta t, so minus v, right? And then down here in the denominator, we have a delta t and a delta t. That's a 1 minus v, and then I'm going to put the delta t with this, delta x over delta t, over that c squared still. Sorry, I got a little wonky there with my writing. It was hard to squish it in. But we've got that. Well, delta x, delta t, that's just u, right? This is delta x, delta t. This is its speed relative to a. Okay, this one was delta x prime delta t prime, right? So this is u. That's the speed of it relative to a, minus v over 1 minus, I have v still, and then this is u again. So u times v over c squared. Okay? And this is our equation for this. This is u prime equals u minus v over 1 minus u times v, v over c squared. Okay? So if we had u, the speed of it, it's kind of the opposite of the situation I gave you, but if we had the speed of it relative to a, you could use this equation to tell you how fast it would appear to be going relative to b. So what speed, so if we looked up and saw that this was moving at 0.9 and they were moving at 0.8, how fast would it appear to be going to b, and you'd use that. Well, that wasn't the actual question I proposed, but you can do that. And so in order to answer the question I proposed, what do? You invert this equation. You find the inverse of it, and that's switch the primes with the unprimes. So u prime, right, in its place, and change all your v's to negative v's. So minus v becomes plus v over 1 plus u prime v over c squared. And there's our inverse equation. Because remember, you can always invert any of these by changing your perspective, right? And in your perspective, you change it and you say, hey, the only thing that happens is A thought B was going to the right, so B just thinks A is going to the left. So it's the same exact equation, but with the opposite sign for all the speeds. Okay? And so be careful with this. So let's write this down here, what goes along with this. U is the speed of C, object C, relative to A. U prime is the speed of C relative to B. That's a B. And V is the speed of B relative to A. Okay? So it's not too hard to use. It'll probably take you a few tries on a couple problems like this to get it kind of figured out and get used to it. In your book, they do an example where they show you if A and B are moving and B fires out a laser beam of light. So C is going at the speed of light relative to B. What would its speed be to A? And if you use this equation and work it out, you'll get the expected answer that the speed relative to A is also still just C. And you can try that. I suggest you try it before you look at how they did it in the book, just to practice using this. And then try some of these practice problems. Try working on some of these, and you'll get used to it. It's kind of one of those things where you look at it the first time and you're like, oh my gosh, this makes no sense. What's moving relative to what? Which speed is which, and what's my situation as they give it to you. But you do a few of them and you kind of get used to how you set them up and how you get used to it. And you'll also find that the same problem, you can interpret it different ways. You can interpret it and switch around who's the observer, who's prime, who's moving in which direction and stuff like that, and ultimately get the same answers. So we had said, here's A, B is moving relative to A. Well, we could solve and get the same, we could figure out what everybody would see by doing this from B's perspective, where B said C was moving to my right at U prime, and A was moving away from me to the left at negative V, and then make this B, essentially make this A, this B, and this C, and we could figure out then how things were doing that. You just have to be very careful and pay close attention to your signs, but you can solve the same problem multiple ways from different perspectives, and ultimately you should get the same answers because these should work like forward and backwards and everything. Okay? That's all there is for relative motion.